Hello and welcome back. Today on the bench again we've got these big high voltage, really EHT, extra high voltage, whatever you like to call them, valves. These are RR3 250s. These are argon, inert gas filled half-wave rectifiers. We've got the same setup as we were using on the to test the 866As. Yeah, where was we? We were testing these RR3 250s. So I've got 3 of them. This one doesn't seem to be working. The one that I said yesterday, said on the other video, it looks like it had been used. So these are argon half-wave rectifiers, and I've just read the data sheet, and as far as I can tell you do not need to heat them up for as long as the Mercury Vapour rectifiers. So let's whack some EHT. And again, suspiciously getting the same figures for current. 228, 250, and these seem to have a larger voltage drop. Let me just turn that up. Yeah, as I turn the current up on the filaments, the EHT goes up. So 500 millivolt drop on the filaments equates to about a 10 volt, 20 volt voltage drop on the EHT. So yeah, go figure. They don't glow prettily like the 866As. Got a bit of sort of glowy business going off in there, and absolutely nothing in that one. This one over here that isn't working has got like the same sort of mesh, but that one isn't working as far as I can tell. So onwards and upwards. Right, we're on to the big CV128s. What does it tell me? It doesn't really tell me anything apart from the just big half-wave rectifiers. No mercury, no gas as far as I know. These have got 10 volt heaters though, so I've had to find another transformer. Luckily it's got very good separation between the primary and the secondary. Let's apply some high voltage, and there we go. Nothing to see really, is there? 220 over there, pulling 220, and that one's pulling 225, which does make a difference from our 230, 250 milliamps. Yeah, nothing really to see, is there? We've got a bigger voltage drop on our, across them. We've got 537. But then again, I'm not sure what we've got going through them, if you're with me, because this is a 12 volt transformer and I'm not applying full mains, probably 220-ish. So yeah, again, nothing to see. Oh, I best put that on. Yeah, note to see. Don't grow nice, but massive beasties, aren't they? As I mentioned, they can do up to 9 kilovolts, 3 kilovolts normalish. You can do a lot more current than the 866A, sort of 1 to 3 amps, I think. The data sheet isn't very. There's not a lot about them. That's what I'm trying to say. So yeah, a bit disappointing. No nice glow. Do look pretty though, don't they? Big beefy buggers. What a shame we can't. What a shame they're not big triodes. Here we are, another day, and we've got these. Oh no, what the bloody hell are they called? Oh, strike a light. DCG4 1000 G or C. We're not quite sure. It also says, I've noticed, 866A. However, unlike the 866As, there's no sort of dispersion of mercury. Oh my, or is that it there? Oh. Well, this is puzzling. Anyway, I've had them going about 30 seconds. Whack-a-day. And they fucking Bobby Dazzlers, eh? looking through the viewfinder, they look more blue than they actually are. To my eyes, to just my eyes and not through the camera, they look more sort of like a purple. But on the camera they look more blue, they look more lovely on the camera. So they're flickering to my eyes, not just through the camera. Maybe, is that 100 Hertz or 50 Hertz? And you know, when I was pointing out the, where do you call it? The filaments. That one's flashing on and off. I wonder if we should have heated that one up a bit more. Right, let's bung the fans on this bloody thing here. So you can't see, I'm sort of trying to... Right, 2.5, right, ho ho. Helps if you turn on the bloody things, doesn't it? Well, are they working without the meters being on? I do not know. And again we're getting this weird same correlation as we was getting before. 228, or 230 in other words, milliamps, and 250 milliamps. So whether it must be the meters. The obvious thing to do, isn't it, is to swap the things over between the meters. That one's settled down a bit, now that one's flickering a bit more. I'm keeping my hands well away, by the way, from the high voltage. Not too hot. And then if you can see, we've got some swirliness going off in there, in the envelope, which wasn't there before. I'm a little bit worried about that. It said on the datasheet 30 seconds, but let's turn the EHT off. Yeah, it says 30 seconds on the datasheet. But yeah, I don't know. I couldn't detect any mercury in there. I mean, unlike a 866A. Aha, now then. I've had some luck sticking the bases. You know, we had a few wobbly bases. And this one's stuck. This had a wobbly base yesterday. And I mentioned that I've tried methylated spirits in the past. Well, that one down there is the one with the base that was completely off. I've resoldered the connections, and yesterday I soaked it in this petrol. But what I did with this other one was get a syringe, fill it full of petrol, let it sort of standing upright overnight with the petrol soaking in, and just applied petrol every now and again. That one's not too bad. It's a little bit loose. So petrol works, but obviously don't go bunging electricity through them when they've still got petrol in the base. Although I did solder them okay without any issues while they still had petrol in them. Obviously the soldering iron isn't hot enough to ignite it. I am worried about this sort of swirling there. That's odd, isn't it? I mean, that looks like it's gone to air. Okie dokie. I must stop saying that. Alright. Well, what should I say? I don't know. We've got a 393A Mercury Vapour. Oh no, let's try again. We've got a 393A Argon Mercury Vapour Thyratron. We test these in a bit different way. I didn't really want to build a whole power supply, so what we've got DC going through the top there, through its anode. There's the filament. The filament, if I whiz you around a little, filament there is the same, so we're feeding the filament 2.5 volts AC. The centre tap of that filament transformer is going to 100 to 100 microfarad cap. That's got a load on it, which is a 800, what is it? 820 ohm resistor, 50 watts or something like that, 150 watts, God knows what it is. I dare say it'll tell me, but you get the picture. Blah blah blah. And we've basically what the difference with a rectifier to a thyratron, it has a grid, it has a control grid. I'm controlling the grid with DC using this pot, because for some weird reason my 0 to 30 volt power supply, bench power supply, won't go down to 0 volts. So to get this to turn on, we have to go below 5 volts. At the moment, basically I've got my big bench power supply, high voltage power supply connected to that via a diode. Diode's there to protect the power supply. So I'm turning the power supply up now, only to 100 volts, but it's got a current setting of 1 amp. With a DC grid, on the grid, it will just come on, it won't go on and off, we won't be able to control it. We need an AC sort of, or an alternating signal to be able to regulate this. So it's just basically going to come on. Right, 100 volts, blah blah blah, 2.5 on the heater, on the filament should I say. Let's start turning the grid voltage down. You'll see a spot, there we go. And as you can hear, my big bench power supply is struggling a bit. You can hear it, it's current regulating. So now it's on constant current mode. I could turn that up, but I don't want to. Well, let's turn it up, let's for laughs. No, that's not really making any difference. Okay. So we're pulling 112 milliamps, but if you look, our grid voltage is jumped to 19 plus 19 volts instead of minus whatever it is. And we are getting, spin you around, 88 volts coming out. So it is dropping 22 volts between the anode and the filament. So this one does glow, as you can see, a pleasing bluey sort of colour. Yeah, I was thinking with a bit of argon in there it might, you know, have a bit more of a different fluorescence, but no. Prior to warming this up, I couldn't see any mercury in it at all. I thought this was like the getter down here, and I still think it is, but yeah. So I can't turn that off now by adjusting the grid. So the only way I can turn that off is by either turning the filament off or the big HT power supply. And there we have it. Do you want to see any more? I'll film a few more. I mean, if you get bored, just turn the video off. Here's number 2 ready to test. They seem to trigger at about minus 2.9 volts. Minus 3.9. I lie. There we go, that one triggered a bit higher voltage. Ah, interestingly now, over there that's saying the grid is -1. Interesting. If I lower you down you can sort of see, or I hope you can see, hopefully you can see there's like a beam of light, which I presume is electrons, going through there's like a slit in this shield. Oops, sorry. There's a slit in this shield. As you can see, the electron or light or whatever fluorescence, I'm not quite sure, I know there's a word for it but I can't think of it, is flowing through that slit. So I said in those 866As that the tubular element might be focusing the electron path, and this seems to bear that out. The other thing that these have got, which is interesting, I'll just show you that, is this, my gubbins, here. I've never seen that in a valve before. I wonder if that is the grid. I wonder, because I can't, yeah, I don't know what the grid has obviously got to go between the filament and the anode, so it must be in there. So that can't be the grid. Interesting, I don't know what that does then. This one is running at a lower current, I don't know if you can see. So this one is acting a bit differently. The other one was running at 113. Oh, and interestingly, it's only doing 64 volts. And I'll pop another one in. We've got 3, so I'll pop the last one in. Oh, this one hasn't been on for long. There we go. And interestingly, this one's running at a higher current, and it also did that, the grid voltage going positive. The other one that we just tested didn't do that, and it was pulling less current. Let's see what happens if we bung it up to, let's just pop you up a bit. Just see what happens if you turn it up to 200 volts. I can't see any difference as we increase the voltage and therefore the current, can you? Well, maybe a little bit brighter. Right, so that's our last valve, I think. The only ones, oh no, there is 2 more valves that we looked at but that we haven't tested, and those are the GU25s. I'm going to go and test it. I don't think you want to see that. We've seen enough glowing valves. I have got some really big rectifiers, which I suppose I could test. What do you reckon? Do you want to see some more big Mercury Vapour rectifiers, or aren't you bothered? Well, at this point I'll say ta-da to those that don't want to be bothered with it, and keep watching to those that want to see some Mercury Vapour rectifiers. More in a moment. Okay, for those of you still around, this is a VT42A or an 872A Mercury Wave half-wave rectifier. I've not got AC going in, we've got DC going in again, and it's been heating for about the last 30 minutes. The heater voltage is voltage. I have trouble seeing my T's. The heater voltage is 5 volts at, what is it? Oh, you bastard, what is it? The heater voltage is 5 volts at about 8 amps, so it's a thirsty old beastie. We've got a different filament transformer because it needs a hell of a lot of current, and we're going to be trying to power it up using my high voltage bent supply. Well, okay, we've got about 50 volts there. Right, what am I doing wrong? I best have a look at this, one moment. Okay, we have success of sorts, although it's you've got some fireworks in there, as you can see. It has been heating for a good while, so you can hear the transformer. It's not getting hot. Yeah, so we're pulling 400 odd. We're pulling 400 odd, 430 milliamps. As you can see, we've got an occasional spark. This is a VT42A, 872A, in other words, Mercury Vapour rectifier, capable of 10 kilovolts PIV, and quite a lot. Right, I best switch that off a second because my resistor is cooking. So this one is interesting. A bit closer, you see the filament? It's different on this one. It looks like a folded piece of some sort of metal, maybe some sort of nickel, and it's right at the top. I can't really see the anode at the moment because I've only just started heating it up. I'll just pop you down. I'll zoom you in. You can see there the anode is just underneath here. Righto, last one. This has been heating for about 2 minutes, which seems to be enough. We're at 4. Did you say 4? Yes, 4 volts. That's a bit better, isn't it? That's a bit more spectacular than the last one. The 825 or what it was. No, it wasn't an 825, whatever it was. I've been doing that many volts, can't remember. That's pulling 350 milliamps. Jesus Christ, I wish it wouldn't do that. The wind's getting up outside. Yeah, loud noises when you're messing about with high voltages, not beneficial to the old ticker, is it? What I shall try and do is power this up later on when it gets dark. They always look better in the dark, don't they? And music sounds better in the dark. Unfortunately I haven't got a load of these, so they're really just, yeah, things to pull out now and again to power up and admire, really. Oh, here's the tube going in the dark. No lights on. See how bright it gets. Quite bright, isn't it? Turn that off a minute and try again in a sec. Quite spectacular, isn't it? See the blue glow a lot better in the dark. Well, I think this about wraps the Mercury Vapour rectifier video up, the second one anyway. Thanks very much for watching. Ta-ra for now.